Welcome back. In this part, we are going to take a look at the standard entry sequence. Okay, so for many compilers, the standard function entry sequence is the following. Okay, is the following. So here, this is the standard entry sequence. Okay, for functions. Okay, so here we push EBP, and then we move ESP into EBP. Okay, so the current address. Okay, the current address on the stack into EBP. Okay, so EBP is now pointing to the top of the stack. Okay, on the top of the stack, and then we reserve some space. Okay, and here X is the space. Okay, X is the total size in bytes. Okay, for all automatic variables used in the function. Okay, so for example, here's the C function code fragment, okay, and the resulting assembly instructions. So, for example, if we have this one, so we have this function. I told you need to have a basic understanding of the C programming language or C++, okay, but I encourage you to be knowing C programming, okay. You can find the link to that tutorial in the description. Okay, just click on the title of this video and you will see that link to that video. Okay, to that exact video or playlist. Okay, that you can watch to get a quick introduction to C. Okay, so here we are having a function that returns a void. Okay, which means it returns nothing. Okay, and it's called my function. Okay, like this, it's called my function, and inside here we declare some three variables. Okay, A, B, and C. Okay, like that. Okay, so let's take a look at now these assembly instructions. Okay, right here. Okay, so this one here, if we use push EBP, here we are saving the value of EBP. Okay, we are saving the value of EBP on the stack. Okay, so EBP on this line, EBP now points to the top of the stack. Okay, on this line. Okay, so from there, here space is allocated on the stack for the local variables. Okay, and here we have three variables and they are integers. Okay, so we are reserving 4 bytes for each. Okay, 4 times 3, 12 bytes. Okay, so that's why we are having 12 here. Okay, so we are reserving 12 bytes. Okay, so from there we have let's go down here. Let's go down to here. Okay, and this means local variables can be accessed by referencing EBP. Okay, so let's consider this code here. Okay, this code here. So for instance, if A is equals to 10, okay, and B equals to 5 and C equals to 2. Okay, like this. Okay, so this is going to be the corresponding assembly instructions. Okay, this is going to be the corresponding assembly instructions. So we are going to move EBP, we are going to use the minus operator, then 4 bytes. Okay, 4 bytes, and then we are going to store 10 into this location. Okay, into this location. Okay, so we are subtracting the current pointer address. Okay, where EBP is pointing to, and then we are reserving 4 bytes. We are moving 10 into this 4 byte location. Okay, and then we are doing the same with 5 and then 2. Okay, so as you can see, the interval here is 4 bytes. Okay, 4 bytes, 4 bytes, 4 bytes. Okay, which means we are reserving 4 bytes for each integer. Okay, for each integer, like that. Okay, so this assembly instructions is the same as, oh no, let me try to undo. Control C. Okay, so I'm doing something that I don't want to do. Let me show you something. So yeah, I'm going to fix this one later. Okay, so this one is the same as this one here. These 3 lines, they are the same as these 3 lines. Okay, like that. Okay, so this is the location. This is the location for A, and this is the location for B, and this is the location for C. Okay, so this all seems well and good, but what is the purpose of the EBP in this setup? Okay, and why do we need to save the old value of EBP and then point EBP to the top of the stack? Okay, so this is only to change the value of ESP with the next instruction, isn't it? Okay, let's see. But the answer to that is that we're using here function parameters. Okay, so we say that the question was, what is the purpose of EBP in this setup? Why save the old value of EBP and then point EBP to the top of the stack, only to change the value of ESP with the next instruction? Why is it that? Okay, and the answer to that is that the concept of function parameters. Okay, so let's consider this code down here. Let's go down here. So we are going to have a certain function. So let's go back. Okay, so I'm going to create this one. Okay, I'm going to create this one because I messed up everything. I messed everything up. So let's go back. Okay, and then let me try to delete everything, okay, that I messed up, like that. Okay, like that. So here we are having a function that doesn't return anything, so it's void, and here it's called my function 2, and here we are having some parameters. Okay, we are having some function parameters x, y, and z. Okay, so from there inside we can do something. Okay, let's take a look at what we do on the stack. Okay, let's take a look at what we do on the stack in that function. Okay, so this one is the same. Okay, so this function here, this one here, this C code is the same as this one here. Okay, this is the corresponding assembly code. Okay, so as you can see here, we are pushing EBP on the stack, and then we are moving ESP into EBP, and then we are reserving 0 space, like that. Okay, we're reserving 0 space. So here, no local variables. Okay, most compilers will omit this line. Okay, they will omit this line. Okay, so which is exactly as one would expect. Okay, so what exactly does EBP do, and where are the function parameters stored? Okay, and the answer is found when we call the function. Okay, so let's call the function. So here we call that function, and then we supply these three arguments. Okay, we supply them. So this will create the following assembly code. Okay, which is this one here. Okay, so we are going to push 2 on the stack, and then we push 5 on the stack, and then we push 10 on the stack, and then we can call our function. Okay, we call our function my function 2, like that. Okay, like that. Okay, so you should remember that the call x86 instruction is basically equivalent to having this one here. It's equivalent to having push EIP then plus 2. Okay, and then we can jump to this function. Okay, it's the same. Okay, so here this one here returns the address. Okay, return the address. Okay, or the current address. Okay, like that. Okay, so from there let's go to this one. Okay, so it turns out that the function arguments are all passed on the stack. Okay, therefore when we move the current value of the stack pointer, which is the ESP, into EBP, we are pointing EBP directly at the function arguments. Okay, so as the function contents pushes and pops values, EBP is not affected by ESP. Okay, and remember that pushing basically does this thing here. Okay, it does this thing here. We are subtracting ESP. We are subtracting 4 from ESP, and then we are moving a certain value. of x, okay, x into ESP, like this. Okay, so here we allocate space for the new stack item, okay, which are 4 bytes, and then we put a new stack item value x, okay, in the stack. Okay, so this means that first the return address and then the old value of EBP are put on the stack. Okay, therefore EBP inside the square brackets points to the location of the old value of EBP, okay, which is the same as having oh, we talked about that. Let us go up here. Okay, which is the same as having this one here, but positive. Okay, it's the same as having something like this, but this plus is positive. Okay, it's positive. Okay, so this one returns the address. Okay, and the EBP plus 8 points to the first function argument. Okay, and here let us take a look at this one here. So let's have some sample idea. Okay, so I'm not going to give out that instruction, but you should know that the stack pointer value may change during the execution of the current function. Okay, so in particular, this happens when parameters are passed to another function and the pseudo function, okay, which is called the, let me go down here, it's called the alloc, that one. Okay, alloc. Okay, alloc, when that one is used. Okay, so this means that the value of ESP cannot be reliably used to determine the memory location of a specific local variable. Okay, and to solve this problem, many compilers access local variables using negative offsets from the EBP registers, okay, which we used here, right here. Okay, right here. Okay, so this allows us to assume that the same offset is always used to access the same variable. Okay, the same variable, or call it a parameter. Okay, and for this reason the EBP register is called the frame pointer, or FP. Okay, like that. Okay, so in the next part we shall take a look at the standard exit sequence. Okay.